Suggestion number 3. Reconfigure on the fly. Now, many system services have a configuration file that they consult when they start up. If you subsequently edit that file, the daemon isn't magically going to notice that it's changed. So some daemons are written to respond to the SIG-HUP signal by rereading that file. Now, it's likely that there are only specific points in the daemon's workflow where the configuration can safely be changed, so we can control where the daemon is and isn't willing to reconfigure by manipulating the process mask. The program I'm going to show you just prints lines of text, one line every 3 seconds. Each line consists of a specified number of repetitions of a specified character. For example, it might print lines of 10 T's or 25 W's. The program is configured by a file which contains 2 lines specifying the character and the repeat count. Let's see what that file looks like. And you'll see here it's set up to print lines consisting of 10 letter B's. I've put the file in /tump for convenience. In reality, it will be more likely to be in /etc. So now let's run the program. It's called reconfigure. And here it is busily printing lines of 10 B's. We'll leave that running, and in the right-hand window we'll edit the file. We'll change the B to an X, and we'll change the 10 to 20. We will save the file there, and if we look over in the window on the left, of course, we see that nothing has happened. The program is still continuing to print its lines of 10 B's. But then here's the exciting bit. If we send a SIG-HUP signal to the program, then the program rereads the configuration file and starts printing lines of 20 X's. Okay, well, we'll stop the program running now. I think we've shown what happens. So let's take a look at the code. Here's the program. Here's the main printing loop. It's an infinite loop. Each time round we have a nested loop that loops printing the specified character C for the specified number of times. That's in the variable count. These 2 variables are declared as globals up here. Now the code to read the configuration file is shown here. It's called read config file. You'll see it opens the file. It makes 2 calls on getLine to read the 2 lines out of the file, and that it parses the values for C and count out of the file. And then just for debugging, it prints out the values that it's read. Coming back into the main program, this read config file function is installed as the signal handler for SIG-HUP signals. And then we raise the signal, that is to say we send it to ourselves, which will cause the handler to run for the very first time. Now we could at this point, of course, also have just called the handler directly. And that's pretty much it. Then we drop into our printing loop, knowing that if the signal arrives, then the configuration file will get reread. Now, ideally, we should put SIG-proc mask calls around this printing loop to block the delivery of SIG-HUP signals during the loop. In theory, this program might switch character midway through a line, although since it spends 99.99% of its time on the sleep call, in practice this is very unlikely to happen.